Okay, I'm here to talk about memory, how you remember. Now, you've covered learning, and the learning chapter dealt a lot with animals and how you learn simple things like the signaling properties of events and consequences of your behavior. Well, I'm going to be talking about something over the next 2 lectures that's much more familiar to you, which is generally how you remember. Next time I'm going to give you a few hints on how to study and based on what we know about memory in general. But I thought I'd start off today talking about a study that was done a couple of decades ago on what people remember from introductory lectures. And this was done at the University of Colorado in Boulder, and it was sampled from an introductory psychology class, exactly like you guys. And the question was, what do you actually remember if you sit and hear a lecture like this one, and then I ask you about it a couple of days later, what do you actually remember from the class? And they were interested in 3 kinds of information. General topic information, sort of the main points of the lecture. Classical conditioning is about the learning of signals in your environment, would be an example. Detail, so that's kind of an elaboration of the main points that were in the lecture. Maybe something much more specific like classical conditioning depends on the interval between the presentation of the CS and the US would be an example. And finally, they asked about jokes and other extraneous material like announcements. There's going to be a test on Friday and so on. So what they did was they gave a lecture, and then in the next class, which occurred 48 hours later, the students were handed out a piece of paper, and on that piece of paper there were statements from the lecture. And they were asked to simply rate on a scale of 1 to 5 whether or not they had heard that particular statement in the prior lecture. Okay, everybody understand the experiment? And here are the results of the experiment. What you see plotted there is the recognition score, which is for items that actually were presented in the prior lecture. This shows you the average time people said, yeah, I remember that. That was in the previous lecture. So it looks like, you remember pretty well the general points detail, but what's remembered best of all? The jokes and the announcements and the extraneous material. What's actually, this graph is a little misleading because when you do a test like this of memory, where you ask people, did you see this statement before? Did you hear this thing before? Everybody has a tendency to sort of say yes, generally. And so you have to subtract out the times that people say yes to things that didn't actually occur. Those are called false alarms. You may have covered that a little bit in your sensation and perception chapter. So what we have to do to get a true recognition score of your ability to remember is to subtract out the false alarms. And when you do that, you get a pattern that looks like this. So essentially, if you're looking at accurate retention of classroom material, what you find is that you basically just remember the jokes and the extraneous material. It's really heartening to us professors who have to give lectures to know that what you really remember are the jokes and not the details or the general points of the lecture. Now, it's not quite as bad as this, and I'll come back to this later on, maybe next lecture, and I'll talk about what this means in a little bit more detail. But as I said, this is a talk on memory, so let's start off by asking a functional question about why you even have the capacity to remember. You may remember when I was in here before, I talked about the development of psychology and the distinction between structuralism and functionalism. And functionalism was a movement in psychology that argued that you can't really understand a psychological process unless you know something about what it's for. So as William James said, you can't study a house or understand a house by studying bricks and mortar. You have to know what the structure's for in order to understand why the bricks and mortars are important. They play a role only in the general function or operation of the system. So if you look at the physical body, you have lots of organs in there, hearts, lungs, kidneys, and so on, and they're each designed to do a specific thing. Like your heart is designed to pump blood, your lungs to get oxygen, and so on. And to understand structurally how those things work, you need to know something about the function of those organs, because structure follows function. So, why do we have a memory system? You can all remember why. Why did memory evolve? Well, you might think, usually if I ask this question to somebody, the answer that I get is, well, memory evolved so that you can remember the past. You know, remember what happened to you yesterday. That's why you have memory. And memory is sort of like, you know, what you have in your computer or flash drive or your cell phone. It sort of takes the information in, stores it somewhere, and then you can get it back later. That's kind of what most people think memory is and how it works. But actually, if you think about it, nature would not have given you a memory system that simply reproduces the past. There are a lot of reasons why, but one main one is that the past can never occur again. In fact, that violates the second law of thermodynamics. The past can never occur again, so you wouldn't want to evolve a system that simply reproduced what happened to you yesterday or the day before. Instead, what you want is a system that helps you use the past in combination with the present to generate some kind of an adaptive or beneficial response. You might, for instance, use the fact that you'd encountered something before to know whether to approach it or avoid it. But the bottom line of this is that it's unlikely that nature evolved a system simply to reproduce exactly what happened to you in the past. This is a very different way from how you typically conceptualize memory. Now, a better way to think about memory is to think about it in the same way that you were taught to think about perception. Now, you just got tested on perception, correct? Well, one of the things that you learned about how your perceptual systems operate is that they operate kind of not by literally seeing or hearing what's out there in the world, but by making a sort of guess about what's out there in the world through a combination of top-down processing, which was expectations, and bottom-up processing. So what perception does is it uses the visual signal that comes into your eyes, along with your expectations of what might be out there, to generate the thing that you actually see. Let me give you a couple of examples of that. So you may have seen a representation like this before. This is something called a Necker cube. Now, as you look at the Necker cube, how many of you think that the side that's facing forward is kind of down and to your right? Raise your hand if you see it that way. So the front of the cube is sort of down and facing to the right. On the other hand, how many of you see the cube facing up and to your left? Raise your hand. Well, for those of you watching this on tape, it's about 50-50. Half the people see the front of the cube is facing down to the right, and the other half see it up to the left. How many can see it both ways? Everybody. Now, you explain to me how this is possible. The actual visual information, the data the electromagnetic information that's coming into your retina is exactly the same. It's not changing. I'm not flipping slides in and out so that you see different things. It's exactly the same visual information, but yet you literally see two completely different things. This shows you that your perception, your visual perception, is like a problem-solving process. It's interpretation. You are taking the visual information and you are solving a problem about what might be out there in the world. And in this particular case, the information that you're getting visually is ambiguous. So your brain doesn't know how to solve this problem. So it gives you alternating solutions to the same visual information. Well, why would you want to design a system that way? I'll give you a second example. I'm going to write on the board here. Can anybody tell me what this is? Your grade on the test? That's an A? Okay. What's this? Loud. What's this? Loud. What's this? How about that? How about that? How many of these could I draw? How about this? I could draw a lot of those, couldn't I? The actual visual information that's going into your retina right there is changing dramatically. But you are instantaneously able to recognize that as an A. How many different forms of the visual pattern could I put up there? Unlimited. But you can instantaneously recognize it as an A. And we're only talking A's. We could talk B's, C's. You are able to take me and see me as a constant person, even though as I walk around and turn around, the visual image that's coming into your head is changing radically. But you are able to instantaneously solve that ambiguous visual information problem and decide that who I am and that I'm staying constant in size and shape. That's remarkable. The reason why you're able to do that is because your visual system does not simply respond to what's out there in the world. Your visual system is making predictions. It's guessing about what's out there in the world based on expectations and built-in organizational principles. Now, why am I telling you all of this? This is a lecture on memory. Let me give you one more example to illustrate this. When you look at that figure up there, do those two monsters look like they're the same size to you? The one in the back looks a little bit bigger, doesn't he? Well, you may not believe this, but actually the visual image that's coming into your eyes is exactly the same. Those guys are exactly the same size. You see the one in back is bigger because the information that's getting to your brain is telling you, because of the perspective cues, it's telling you that that one monster is behind and chasing the other monster. Your brain thinks that one is behind the other, but yet it sees the perceptual image being exactly the same size. The only way those things could be exactly the same size if they were spatially distant from each other is if the one behind it is bigger. So your brain actually creates a false illusion. It makes you think that the monster in back is bigger because that's the way it's learned to interpret the world. So perception is an interpretive process. It's not literally taking the visual information as it's coming in. Well, what I'm going to claim to you over the next half hour or so is that memory works exactly the same way. So what you remember is not literally what happened to you, but an interpretation that you're making about what must have happened to you in the past. That means that it ought to be relatively easy for me to create illusions of memory in the same way that we can create illusions of perception like the ones that I just showed you. And I'm going to do a couple of examples here to show that. One example that I'm going to do right now is I'm actually going to get you to remember something that didn't occur. I'm going to say that again. I'm about to do something where I will get you to remember something that didn't actually occur. In fact, for some of you, you will remember the thing that didn't occur better than the thing that did occur. That would not be possible if memory was operating like a flash drive. If the way it worked was like your computer, and you just stored information on a hard drive and then went in there and got it, how could I possibly get you to remember something that was never stored in the first place? You don't believe me, do you? Well, I'm going to read you a list of words, and I want you to memorize these words. And I'm going to ask you questions about them. Everybody got it? This is a memory experiment. Do not write them down. Listen closely. Thread, pin, eye, sewing, sharp, point, prick, thimble, haystack, thorn, hurt, injection, syringe, cloth, knitting. Got them? Remember them? Okay, let me give you a second list. Listen closely. I'm going to ask you about this in a second. Listen closely. Hard, light, pillow, plush, loud, cotton, fur, touch, fluffy, feather, furry, downy, kitten, skin, tender. You got them? Now I want you to look at me, and I want you to count backwards from 100 by threes. Can you do that out loud quickly now? 100, 97, 94, 91, 88, 85, 82, 79, 76, 73, 70, 67, 64, 61. Okay, now, that just was to distract you a little bit. Now I'm going to go back and ask you some questions about those memory lists I read to you. Okay, on the first list that I gave you, raise your hand if you remember me saying point. All right, so I would estimate maybe a third of the class is remembering point as one of the items. How about thread? Was that one of the items? Now I would say about 80% of the class is remembering thread. How about needle? Raise your hand high if you remember needle. High, this is high. I would say it's about, what would you say, half the class? Needle was not on the list. Now I just told you I was going to do this. You remember needle, both of you guys did it. You remember needle at a higher rate than you remembered point, which was on the list. I told you I was going to do this. How many of you remember downy? You sure? Downy. How many remember soft? Raise your hand high. Soft was not on the list. So once again, although you guys are a little bit less likely to say yes now than you were before, it's relatively easy by rigging the list to get you to remember something that didn't actually occur. And this experiment has been done under controlled circumstances, and you can see what the data actually look like in the laboratory. And the part that I want you to look at is, if you look at the bar on the left, those are items that were actually given to people, and the ones on the right are the ones that were not given to people. And you can see that on average, if you look at the blue bars, if you rig the list in the right way so that you have an expectation about something being there that in fact was not presented, you will claim to have remembered this at a higher rate than something that didn't occur. In fact, it's so bad that if I present these words by male and female speakers and I intersperse them, so half of the words are presented by a male and half are presented by a female, you will not only claim to remember a word that wasn't presented, but you will claim that it was presented in a male or female voice. You will say, I remember it, it was a male, even though it was never actually presented. Well, that's just one of the memory illusions I want to talk about. Here's another one. Flashbulb memories. Raise your hand if you've ever heard this expression of a flashbulb memory. Flashbulb memories are memories for significant events that happen in your life. It can be big, huge emotional things, like maybe a member of your family dying. Doesn't have to be negative, it could be positive. And for really significant emotional events that happen to us, we think often that we can remember exactly what we were doing when that event occurred. And each generation has flashbulb memories that they carry around with them. So for your great-grandparents, they had a vivid memory of what they were doing and where they were when they heard that Pearl Harbor had been bombed. For your grandparents' generation, they had a vivid memory of when President Kennedy was assassinated. Now, you have flashbulb memories, I'm sure. One flashbulb memory that you may have, although you may not quite be old enough, is from 9/11. Do you have a flashbulb memory for what happened on 9/11? Do you remember exactly what you were doing when you heard about the bombing of the Twin Towers? Well, one of the unique characteristics of these kinds of memories is that people are absolutely convinced that they can remember everything that was going on. Well, it turns out that psychologists have looked at these memories, and what you actually remember is often completely different from what occurred. And the way these experiments have been conducted, and I'm going to talk about one briefly, the way they've been conducted is the day after some significant cultural event, like 9/11, psychologists call people and have them answer questions about what they were doing. So usually within 24 hours, a psychologist is on the phone asking people questions like, where were you? What activity were you engaged in? Who were you with? And so on. And then they come back later, maybe a year later, and they call the people back and they say, remember when this event happened? And you go, oh, yeah, man, I mean, I absolutely remember this. I remember everything about it. Okay, well, can you tell me where you were, what you were doing, and so on? Well, there's been a lot of these studies done. The most famous one was about the explosion of the Space Shuttle Challenger. And this happened before most of you were born, back in the 80s. But it was a really tragic event where a space shuttle, they had a teacher on board, and all kids all over America were watching it, and the shuttle exploded. And so what psychologists did was call people and ask them to relate exactly what they were doing when the shuttle blew up. And then a year later, they came back and asked the same question. And I just want to give you some data from an experiment that was done on the Challenger explosion because it's pretty revealing. What you see here is the accuracy, how accurate the reports were a year later. And so the way this is calculated is that I'm not going to go into the details, but a 0 means you were obviously wrong on all of the questions that I asked you, and a 7 means you were completely accurate. Just to give you an idea of what these data mean, 25% of the people that participated in this study were completely inaccurate. So what they thought they remembered and they were pretty confident in turned out to be completely different from what actually occurred. I'll give you an example. One person, the day after the Challenger exploded, reported that they'd heard it in the cafeteria while they were eating lunch, and that they had felt, quote, too sick to eat. That's what they reported within 24 hours. A year later, they reported, oh yeah, I was in the dorm, and a girl came running down the hall screaming, the shuttle just blew up. No relationship between the two memories. 50%, half of the people in this study reported had an accuracy score of 2 or fewer. 2. That's very inaccurate. Only 3 people in the entire study were completely accurate. Now, so even though you don't remember things very well that happen around emotionally significant events, but what's striking is the confidence that people report in their memories. So they also asked them a year later, how confident are you that your memory is accurate? The mean, on a scale of 0 to 1 to 5, the mean was 4.17, where 5 is I'm absolutely certain that this memory is accurate. 68% of the people who participated in this study gave a score of 4 or greater. 55%, over half, of the people that got 0 accuracy scores gave a confidence rating of 4 or greater. So there's a complete disconnect here between what you think happened and your confidence in your memory and what actually happened. By the way, President Bush has a flashbulb memory of 9/11. And it's been studied. And I just put up an example of this. So President Bush was asked in 2001, this is in December, a couple of months after the event, he was asked at a town hall forum, how did you feel about the terrorist attack? Or how did you feel when you heard about the terrorist attack? Well, Jordan, you're not going to believe what state of mind I was in when I heard about the terrorist attack. I was in Florida, and my chief of staff, Andy Card, actually I was in a classroom talking about a reading program that works, and I was sitting outside the classroom waiting to go in, and I saw an airplane hit the tower. The TV news was on, and I used to fly myself, and I said, there's one terrible pilot, and I said, it must have been a horrible accident. But I was whisked off there. I didn't have much time to think about it. And I was sitting in the classroom, and Andy Card, my chief who's sitting over here, walked in and said, a second plane has hit the tower. America's under attack. He was asked again a month later, and here's his response there. Anyway, I was sitting there, and my chief of staff, well, first of all, when we walked into the classroom, I had seen this plane fly into the first building. There was a TV set on. And you know, I thought it was a pilot error, and I was amazed that anybody could make such a terrible mistake. Something was wrong with the plane, or anyway, I'm sitting there listening to the briefing, and Andy Card came over and said, America's under attack. Well, what President Bush is saying here could not possibly be accurate. And the reason why I can say that is because there was no footage available of the 9/11 attack. The plane, you've seen the image now on TV since, but at the point where he was in the classroom, that video was not available. It had never been shown. So what he was remembering, in fact, was false. He could not have seen the plane go into the tower because that video did not surface for hours later. Are you following me here? Well, this led to all kinds of conspiracy theories all over the world. For example, freeworldalliance.com said Bush slipped because immediately people recognized that he must have been lying. Bush slip reveals total 9/11 complicity. Complicit factions of the U.S. federal government, including all upper-level members of the Bush mob, actually filmed their own attack on New York's World Trade Center, and Bush admitted that he watched it. Bushwatch.com. The most benign conclusion, then, is that Bush was not telling the truth when he told Jordan that he saw the first plane hit the first tower. The Guardian, a respected newspaper in England. The story that he was watching TV contradicts reports from correspondents at the time that he got the news in a phone call. So was Bush lying here? If you have the view that memory acts like a disk drive or a flash drive, if that's the way you think memory works, then how could he possibly be remembering something that didn't actually occur? But I'm telling you that that's not the proper way to think about memory, that memory is actually an interpretation. That what you remember is a blending of what you think must have gone on in that situation, just like the Necker cube and the two monsters. It's an interpretation process, and in fact, a very natural part of the way we remember. Now, obviously, this vision of memory, I'm telling you that the memories that you have, the memories that you carry around with you, are not literally true often, but rather are a reconstruction of what you think must have gone on in that situation. This has implications for all kinds of things. Think about eyewitness testimony, for instance. Do you know that the single most convincing piece of evidence that you can have in a court of law is eyewitness testimony? I saw that person do it. That's the killer. That's the single most persuasive piece of evidence to a jury. In fact, if you don't have eyewitness identification or eyewitness testimony, it's often said to be a, quote, circumstantial case because you don't have an actual eyewitness. Well, it's relatively easy for me to get you to remember things about an event that didn't happen. I can also shape your memory for a prior event to make you think things happened in a way that's slightly different from the way that it happened. Let me show you an example of that. This is from a study that was done some time ago. And the way it worked was people were asked to come in and watch a video of a car accident. And there were two cars that got into an accident. Now, everybody watched this film. And then afterwards, different people were asked different questions about what happened. So they were acting like eyewitness testifiers to the accident. In one case, people were asked, you know that car accident that you just saw a few minutes ago? Tell me. How fast were those two cars going when they smashed into each other? Another group who'd watched exactly the same film were asked, remember that film that you just watched? Tell me, how fast were those two cars going when they contacted each other? What have I done here? I've switched two words. In one case, I said smashed, and in the other case, I said contacted. Well, people report significantly different memories depending on whether I say smashed or contacted. If I say how fast were those two cars going when they smashed into each other, you estimate the speed as significantly greater than if I say how fast were they going when they contacted each other. Not only that, you remember details about the event that are different. So if I ask you, was there broken glass? You are much more likely to say yes if I say how fast were the two cars going when they smashed into each other than if I said contacted. It gets worse. I can do this. I can say, remember that car accident that you saw? Where that little Avalon was coming down the street and it ran through the stop sign, turned the corner and smashed into that pedestrian? Well, do you remember whether or not there was anybody standing on the other side of the street that might have witnessed that? Just imagine I'm a defense lawyer, or I should say a prosecutor. Well, I don't know. I don't think there was anybody on the other side of the street. Well, you know, there was no stop sign, and the person didn't really run the stop sign, but noticed I put that in there. If I later on ask you, did the person run a stop sign, you say yes. So all I did was throw it in there in my leading question. So as you were going down the street, as that car was going down the street and ran the stop sign, turned the corner, ran into the pedestrian, was there anybody on the other side of the street? You think there was a stop sign. There was no stop sign. I'm telling you something pretty significant here. I'm telling you, and I just showed you that I could get you to remember something that didn't occur. I'm telling you here that it is relatively easy for a skilled prosecutor or defense attorney to get you to remember things differently based on how I ask the question. I can throw in little things into my questions, little leading things, that will get you to remember things that didn't actually happen. This is very serious. Eyewitness testimony, in fact, is one of the least reliable forms of evidence that you could use in a jury trial, but yet it's the most impressive. Well, who do you suppose is being taught all the stuff that I'm telling you today? What do you think is a regular part of the curriculum that you get in law school these days? The kind of stuff that I'm telling you. Okay? The same applies to lie detector tests. The way your memory system is designed is not to literally recover what happened to you in the past. Your memory system is designed to have you remember what might have happened given the information you know now, and you form kind of like an amalgam of what's happening now and what happened in the past. So I can not only have false memories, but I can implant memories because of the basic reconstructive nature of the memory process. Well, I was giving a talk one time to somebody, to a group, and somebody came up to me afterward, a kid, somebody about your age, a little younger maybe, and said, what you've told me today is extremely upsetting to me. In fact, you could have told me that the Soviets or the Russians had just launched a nuclear arsenal on the United States, and I wouldn't be any more upset than I am right now. I'd just given this talk, okay, and I'm like, oh. My mother recently died, And the only thing that's kept me going, this is him talking to me, the only thing that kept me going is my memory of her. And you're telling me that all of the memories that I have of my mother are wrong. And literally, tears welling in his eyes. Not a question you want to get after a talk. What I explained to him, though, and what you need to understand, is that even though memory's reconstructive, it doesn't mean that it's always wrong. In fact, a lot of the time, your memory's very accurate, just like in perception. So most of the time, when you're walking around and you see a tree, there is in fact a tree there. Memory is accurate. But it's not accurate to the degree that you think it is, and it's very easily led astray. So don't get too depressed about this. Just be cautious about those memories. All right. So what is memory? Memory, and now I'm going more back to what you'll see in your textbook. I gave you sort of a general introduction to what memory is, and now we're going to talk about some of the things that's actually in your textbook and in your chapter. What is memory? Well, it's the capacity to preserve and recover information. And there are three components to this process that you need to know about. The first is that we assume that memories are formed through a process called encoding. So encoding is the process through which memories are formed. Storage is the process through which memories are maintained over time. I didn't say that you didn't store memories. You do. You store memories, but what you actually remember is not literally what you stored. And that's because there's a third process called retrieval. And retrieval is the process of how memories are recovered and actually translated into performance. And here's a visual that shows you the distinction among these three types of processes. So I might give you a picture of a cat, or excuse me, I might give you a list of words, and cat is one of the words on the list, and you might encode that information by forming a visual image of a cat. You then store that information in some way in your head, and later on, I could ask you, was there an animal on that memory list? And you have to go through a process of figuring out what was presented on in the previous episode. And that's the process of retrieval. So you might call to mind lots of animals and see, oh, there's that little image of a cat. So those are three processes that you need to remember: encoding, storage, and retrieval. And we'll be talking about a little bit of those over the next lecture and a half. Okay. Now, another distinction that we make in standard memory theory is between short-term memory and long-term memory. So we've run experiments to study how you remember over the short term and how you remember over the long term. Short-term memory is the system we use to store, think about, reason with information temporarily. So you may not have thought about this very much, but you actually do remember things over very, very brief intervals. A good example of that is language. So if you notice, language is serial. One word follows another word. And often, in order to understand a sentence that's being spoken to you, you have to remember the early part of the sentence until you get to the end. In fact, you have to remember not only what the early part meant, but the sound, because oftentimes the meaning depends on you remembering sounds from the early part of the sentence. So you have a system in your head that we're going to talk about in detail that enables you to remember things over the short term. And we're going to talk about 3 different characteristics of short-term memory. We're going to ask, how is information represented in short-term memory? How quickly is information forgotten from short-term memory? And what is the capacity of short-term memory? Those are 3 things that we're going to talk about. I think I'm going to, since we only have 4 minutes left in this lecture, I'm only going to talk a little bit. I'm going to come back to this on Wednesday. I'm going to talk a little bit about how quickly information is forgotten from short-term memory. How many of you believe that you could remember 3 letters for 15 seconds? Raise your hand if you think that you can remember 3 letters for 15 seconds. Be careful now. Are you completely confident after what I've told you for the last 45 minutes that you're going to be able to do this? Let's try it. This is only going to take a couple minutes, so work with me. Here we go. I'm going to read you 3 letters, and then I'm going to wait, and I'm going to ask you to recall them. Everybody understand the task? Here we go. X, B, R. Recall. You know, I was driving through McDonald's. This was a couple of years ago. And I had ordered something. It was a breakfast. And I was coming to work, and I was driving through McDonald's. And I ordered something like an Egg McMuffin. And I got up to the window where they give you the food and you pay. And this kid leans out of the window, and he's got all that stuff on it. He looks at me, and he goes, XBR, man. XBR. No, Egg McMuffin, I said to him. He said, I was in your intro class like 5 years ago. And you said that, like, I couldn't remember 3 letters for 10 seconds. Well, XBR, man, they're still there. Great, okay? I mean, good. 5 years ago, McDonald's, the takeout guy, good. Good. Well, there's a little trick here I've got to do for you in the next minute. In fact, I'm going to leave you in suspense, because we only have a minute left. I guarantee you that when you come back here next time, A, you will remember XBR. It will be on the test. And 2, that I will be able to give you 3 letters, and you will not be able to remember them 10 seconds later. I'll show you how I'm going to do that on Wednesday.